So our next subtopic is that of skills that are required by an. And again, they are arranged in terms of importance. I said 100 represents the most important, and the 0 represents the least important. So when you see some skill of is given 95, then you can know that it is very important. And again, I don't look at all of them. I look at the ones that are most important. The others you can always read for you. So using mathematics to solve problems. Mathematics is one of the key skills that you require. Somehow there is similarity between a skill and knowledge, but nevertheless we are going to look at them. So we are saying that there is the skill of using mathematics to solve problems. You may have the knowledge of mathematics, yes, but you may not know how to use mathematics. How you may have the knowledge of mathematics, but you may not know how to use that skill. So then the know-how, there is the know-how and there is a difference between there is a difference between knowledge and skill. Knowledge is the know-how, okay, is you know something, but the skill is how to use it. So in few words, you're saying that you might have some, you might know a lot of calculus, you might know a lot of mathematics, but when you are given an engineering problem, you don't know how to solve it. And therefore, what we are saying is that you must also develop a skill of using the knowledge of mathematics that you have acquired to solve the engineering problem. And that is what you are saying, that skill is very important. Again, you might know the science, like you know the physics, you know the chemistry, you know other sciences, but if you don't know how to use scientific methods to solve problems, then you're in trouble. And therefore you are saying that you must develop the skill of using these methods to solve engineering problems. Therefore, another skill that you require is that of reading comprehension, because bulk of your studying will involve about art of reading. So understanding written sentences and paragraphs in work related documents. Therefore, you must actually understand the English language. So this is related to the English language, but beyond reading English language and understanding the different words and grammar and spellings, you need to develop the skill of reading comprehension. You read a story or you read a paragraph and you comprehend what is being said. And that is, we are saying, that is a very important skill that you must develop. The other one is that of judgment and decision making, that you must be at a position where you are weighing options. You look at the different options available or different choices available, and then you make a choice comparing the pros and cons of making a decision. So like you are doing some analysis that if I do ABCD, I will have these advantages. Advantage 1, advantage 2, among others. And then the disadvantage of taking that course of action might bring you these disadvantages, 1, 2, 3. So then when you weigh the options, you might give some weight to this. You might say the weight of this one is 10%, this one is 50%, this one is 2%. So when you give it the weight, then it is going to give you some guidance on the kind of decision that you want to make. And that ability to make decisions is very important again in engineering. Let's talk about critical thinking. You are going to be doing a whole unit called critical thinking. I am not sure whether you are doing it now or you're going to be doing it later, but I noticed a unit in first year that trains you to use logic and analysis to identify the strengths and weaknesses of different approaches. So critical thinking involves that you are critically looking at a problem and saying what is the best course of action depending on the current circumstance. So that kind of a skill is called critical thinking, and it is weighted at 75. So it is a very important skill that you must have. Another one is called technology design, which is generating or adapting equipment and technology to serve user needs, so that you are able to say that this system is working this way, but if we applied some technology here, we are going to have this same product doing the same work that it does, but probably better and more efficient by applying probably a very little skill of technology. And therefore, that kind of technology design is very important as well. It's a skill that you are going to develop. Let's say that now you have acquired this skill because it did not be measured, but be on the lookout that you're going to be doing some units, particularly called as I think we have digital system design. Digital system design. So this is like this is a unit that you're going to be doing, I think, in around 4 year or 5 year, that simply trains you how to develop digital systems. Therefore, what we are saying is that developing that skill of seeing how you can use technology to develop or to improve systems or equipment, then that is a very important. We are at 70% now where we have information gathering. You cannot afford to be ignorant. Therefore, you must be able to look for and search for information, find and identify the essential information that you require. So as you study, you might also have come across that you have a textbook with say 500 pages, and you need to solve a problem. You can't read from page 1 to page 500 so that your problem is solved. You need to find a way of gathering information that is most essential. The keyword is the most essential. You are able to find the information and then identify the most essential information. Therefore, that actually becomes very important because in today's world, we are in the world of information age. There is information overflow. Everybody might be sending you some notes and telling you, read this, read that one. Therefore, you cannot afford you don't have unlimited time. What you have is that you require to be able to identify, to look for information, yes, amongst the available sources, but the key word is you must be able to identify the information that is very key to help you solve your problem. Moving on. Writing is a skill, so you must develop a skill of writing, and that allows you to communicate effectively with others. And because you are not solving a problem for yourself, you are solving problems for others, and therefore you must develop skills for writing. Be it written or typed, doesn't matter. But the most important thing is to know that you are going to be communicating information that is going to be received by others, and therefore that kind of information requires to be well received. You cannot afford to write a story that does not please the audience, and therefore you must develop the skill of writing. Active now, I think we are almost reaching where we will stop discussing them. There's active running whereby you don't listen passively and as if you are in a movie theater. What you need to be able to do is to learn actively. Like if I give you a problem, you're able to write it down and break it down into modules that will allow you to solve it. For example, the way you used to do it in high school, like you are given a problem, like you told a man carries a boy who is twice as heavy as his daughter, and then you're told that the daughter is 20 kilograms and the man is 10 kilograms heavier than their total weight. What is the weight of the man? That kind of problem you cannot solve it passively. You actually need to sit down and say, what do I need to do? I need to say that the daughter has weight of 20 kgs, so we will give it D. The boy has the weight of 2D, which is 40, and then the father has how much weight. So I'm not telling you that this is a problem you need to solve now. All I'm simply saying is that the kind of learning you need to do is to break down. You see, solving this problem requires you to breaking down into small sub-modules that you can address, and that kind of learning is called active learning. Another one is that of problem identification. You must be able to identify the nature of the problem and kind of methods you're going to require to use. You cannot see all problems as though they are the same. So some problems will require you to apply calculus, others will require you to apply numerical methods, other problems will require you to apply some just pure basic logic. So that kind of skill is required for it's called problem identification. Again, you can of course read others for yourself for the sake of time. They are quite more or less straightforward, so that you can look at the others, because you are in a university where you can be able to read for yourself and understand, and that is one of the skills that we have said. So there are plenty those skills that are required. So when someone is asking how is calculus applied in engineering? Everything engineering involves calculus. But for instance, one of the training you're going to be given in calculus is how to perform differentiation and integration. This is a task you run in calculus. And once you have learned in calculus, then when you are dealing, say, for instance, in telecommunication systems, this is my field, therefore this is where I can get my example. You might realize that for you to send a signal from the broadcasting station, this is a message, we call it MT. You want to send this message from your broadcasting station to the area where you want the audience to receive it. You're going to do something called modulation. And if you want to do modulation, it is like you are message to a carrier signal. This is an advanced class, so you don't have to worry. And the carrier signal looks something like this. It could look like cos omega t plus phi. So for you to carry this message using this, there is some multiplication that is involved. And then you might actually end up with a message that now requires to be retrieved, at this end so that it becomes back as empty. And for you to do this, you require some integration. And therefore, the skills of differentiation and integration, which is coming from calculus, are going to become straightforward and very important. And therefore, that is just one of the easiest approach I can tell you that you are going to apply calculus. But there are numerous ways that every day you are going to be applying calculus and other mathematics for your engineering. The other question is asking, are we going to learn Python Django as part of programming? No, you're not going to learn Python Django as part of programming. This is a skill you can learn for yourself outside the unit that is going to be taught. You're going to learn the basic skills of programming. And therefore, if you want to develop further, Python Django, I believe, is used for developing mobile apps or web applications. That you can do it on your own. And that is more in IT courses or computer science than electrical engineering. So you may not find us teaching you how to use Python Django. Do we have a course called electrical engineering? Not electrical and electronics engineering. Of course, yes, it is there, and not here in our university, but there are other universities that offer purely as electrical engineering. But like Nairobi University offers it as electrical and information. This is Nairobi, and JKUAT calls it electrical. Just the way we call it, electrical and electronics engineering. Moi, this is JKUAT. Moi calls it electrical and computer engineering. So in Kenya, yes, we may not have pure electrical engineering, but outside the country, you might find those courses. Is the motivation integration? Of course not. I just mentioned that I don't want to take you through the mathematics rigor that you are going to be doing when you are doing, but here you're going to be doing integration, differentiation in different aspects. For actually where I mentioned that you might require some integration is because you are going to find some course terms that are twice the frequency component of your carrier signal, and therefore you're going to do some filtering. And filtering is actually performed using integration. So it is not directly integration, but it is one of them. Yeah, so I think that answers bulk of those questions. The other bit that we need to look at is the abilities, because these are very similar to what we have already covered. So I can actually leave you for yourself to read for yourself the abilities that you require as an engineer. There are plenty of them. They are also weighted the same way we weighted the others. The one that is closest to 100. The one that is closest to 100 is very important. The one that is closest to 0 becomes less and less important. And similarly to the work activities, again, there are some work activities that are going to be that are important. They are also arranged in the same manner. The most important ones are weighting closer to 90 to 100, and the least important ones are weight closer to 0. So again, you can look at these ones. They just prepare you to kind of the work that you are training to become or training to do. So that more or less covers our lecture for today. I can see a question here that is asking, what is the difference between Bachelor of Science and Bachelor of Education in Electrical and Electronic Engineering? And that's a very important question because we have two programs here. Bachelor of Science in Electrical Electronics Engineering. There is a B.Ed, Bachelor of Education Technology in Electrical and Electronic Engineering. These students are doing 4-year course, and these students are doing 5-year course. These are going to become engineers straightforward. You start by getting to the industry, then you are given a graduate engineer after you have graduated, and then after you have practiced for 3 years, and an engineer, then you can apply to become a professional engineer. This student, when they graduate, their market or their purpose is to teach in colleges. There are colleges that offer diploma and certificate courses in electrical engineering. So these students, we are training them so that they can become teachers. That's why it's called Bachelor of Education. Therefore, they are doing it in 4 years. They are not doing everything engineers should do, but we are giving them the most important skills of an engineer. And therefore, in addition, they are doing teaching teaching units like how to teach, how to manage a class, etc. So purely these are becoming teachers. If they want to become engineers, they would come back, do some additional units, and then get a BSc degree. But with the BA degree, they cannot become an engineer. No, they cannot become an engineer with the BEd degree. I hope I have answered that question. A very good question there by Kerosi. What is the difference between Bachelor of Science and Bachelor of Engineering? And more or less, there is no much difference. In Kenya, we actually have Bachelor of Science, and science emphasizes the mathematical rigor of doing the analysis, the design, and the calculations that engineers require to solve for them to solve the engineering problems. Engineering, which is not offered mostly in Kenya, is more concerned with teaching the students the products that are going to solve the products, the problems of the world directly without necessarily going into the mathematical rigor. So I would actually say that Bachelor of Engineering is, in my view, inferior to Bachelor of Science, because the Bachelor of Engineering is like another one that is called Bachelor of Technology. And Bachelor of Technology is like you are training superior technologies, but they are not doing bulk of mathematical rigor that engineers do. I hope I have answered that question. Another very important question, where there is an added advantage of being registered by ABK, and I would say yes, there is huge advantage of being registered by ABK. One, if you want to work for Kenya Power, if you want to work for other bodies that are government bodies, institutions, Kenya Power, KenGen, etc., they would of course require you to be registered with ABK. So there is a straightforward advantage of being registerable with ABK.